Okay, good morning everyone. So this is our first week. It's okay. Kita masih struggle lagi nak bangun untuk kelas. And I'm still figuring out my schedule. Tadi saya tersalah hantar link actually to my other class. So that was why I was late. So I'm really sorry about that. With K19, kita dah cover until vector components. If I'm not mistaken. Were you guys the last class that I taught? Tuesday, K19, yes. Okay. Okay, so let's do a little recap. This is my style. At the beginning of each class, I would like to do some recap to get everyone on the same page as me or at the same page as your friends. So let's use one slide to do that. New slide. Okay. So we talked about we talked about base quantities, derived quantities, scalar, vector, and then we talked about vector addition and then vector subtraction. We also talked about scientific notation, and we also talked about vector components, which was the last part of the class. So let me use my pen. Okay. So just a little recap, just a short one. So we have base quantities, and then we have derived quantities. And as mentioned by your friend earlier, last class, this is something that cannot be broken down. I like that definition. Cannot be broken down. And this guy can be broken down lah. For example, speed, because it's length over time or distance over time, sorry, can be broken down. Okay. And then you have to remember what is base quantities, which is length, is in meter. You have to remember the quantity and also the SI unit. So we have length, we have time. We also have candela, which is light luminosity, time. Okay, all those things. Please go back to the video. And then this one can be broken down such as speed, okay, distance over time, and so on. And then we talked about scientific notation. Okay, so if I have a bunch of number, blah, 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 8, 2, 3, I don't want to remember all the numbers. So I can simplify it to become scientific notation. So for physics, we use 2 decimal points. This is acceptable for the test, for anything really, for our assignments, 2 decimal points. So 9.93 times 10 to the 1, 2, 3, 4 times 10 to the 4. And then if they have units, put the units there. Do not forget your units. Units is very important in physics. And then we talked about vector versus scalar. Okay, so scalar only has magnitude, while this guy has magnitude and direction. Okay, and then vector, if you want to add vectors, okay, now I want you guys to tell me what are the techniques to add vectors? Techniques to add vectors. Does anyone remember?
Is it the tip to tail?
Yes, correct. So it's tip to tail. What else?
Tail to tail.
Tail and
Triangle rule.
Angle rule.
triangle rule, correct. Okay, so tip to tail, as the name says, you go for one vector first. Let's say this is vector A, and then this is the tip. You connect it to the tail of the other vector. So that is tip to tail. And then tail to tail, your A vector and your B vector are connected at the tail like that. So how do we find the resultant vector? We go from the initial point to the end point. So initial point to the end point. So I started with vector A. So vector A starts from here to here. This is the tip. This is the tail of B. And then I go over here. This is vector B. This is the end. I go from point 1 to point 2 over here. from the beginning to the end. I shouldn't label it as 1 and 2. Beginning and end. Okay, same case as this guy. No, for tail to tail, you can only add 2 vectors. And how do you find the resultant vector? Is you have to make a line that is parallel with the vector. Line that is parallel to vector B, a line that is parallel to vector A. Gambar ni tak cantik. Make it parallel. So, and then you go from the tail, and then your resultant also is connected by the tail to all other vectors. So all tails are together, okay? And then you get your resultant. So this is your resultant vector. Resultant vector. Resultant vector always have to have that arrowhead. Kena ada. You don't put this, it's wrong. It's just a line to me. You draw this in exam contohnya. You only draw a line. I say it's wrong even though the length is right, but you didn't give me any direction. So the arrowhead, this guy over here is very, very important. You need to label it, or you need to know where it goes, okay? So just simply knowing the length is not enough. Okay, so vector kena ada magnitude and also direction. Okay, and then we talked about vectors addition, tip to tail to tail, triangle rule. Triangle rule, we have to use the law of sines. Okay, I believe you know this already. And then there was an equation called, apa nama dia, tak ingat lah. Let's go back to the slide. Where is it? Okay, so it's this guy. C squared equals to A squared plus B squared minus 2AB cosine C. What is the cosine C? What is the angle? It's the angle opposite to the length that you're finding. This is the length of the resultant vector. This is the angle. Okay, so using the triangle method, triangle rule, you have to know the angles in the triangle itself. Okay, so it's a little bit different than tip to tail and tail to tail. Tip to tail and tail to tail is more of drawing. Triangle rule is more to math. Okay, it works, all works. But preferably I would use component. Component paling senang sebenarnya, and we will see why. Right. Okay, what else do I need to cover? We talked about this. Okay, we haven't talked about this one. Okay, so if you're adding vectors, right? Where is my slide? Okay, if you're adding vectors, let's say I have, I'm adding weight. Weight is in Newton, and I'm adding friction, which is also in Newton. Boleh, because they have the same unit. Basically, they are of similar category lah. I would say the same kind. So they are both forces. So you can add them together. But if you wanted to add one vector, which is weight, and another vector, which is position, you want to add increase weight with Sharifa's position, can't be done. So you have to have the same kind. So weight with weight, forces with forces, weight is under forces, and then a position with position. What else? Velocity with velocity. Tak boleh add velocity with weight, something like that. Okay. So that was our recap. So let's continue. So to vector components. Vector components kita baru masuk sikit je. We use the animation, which I really like. I hope you liked it too. So basically a vector can be broken down into its components. A vector can be broken down into its components. It's not necessarily X and Y. Tak semestinya. Tapi yang menyenangkan kita, the one that makes our life easy is the X and Y. Because X, we know the direction is to the right. And Y, we know the direction is up. For positive lah. Going down is negative Y. Going left, oh saya punya tangan terbalik, tak mirror. Oh dia mirror. Going to the left is negative Y, right? So this is the conventional direction lah. Conventional direction. Conventional direction. If I see this, okay, it means nak cakap macam standard lah, standard punya direction. If I'm saying, okay, let's use the conventional direction. So it means that X to the right and Y up is positive. x to the left and y down is negative. That's the conventional direction. But you can actually define your y to be positive downwards. So that's not conventional, but you can. You can. So this is the beauty of vector lah, actually. But let's stick with the conventional direction first so that we don't confuse anyone here. Okay, kita stick to conventional direction first. Okay, so as I mentioned before, a vector can be broken down into its x and y. A vector can also be broken down into other components, which is like this. So this is a vector. This is vector A. Okay, vector A. The red line is vector A. The red arrow, sorry. The red arrow is vector A. And I'm breaking it down into vector small a, vector small b. Does it look familiar? It should be because it's basically a tip to tail. So I can go backwards. I can do this in reverse. I said, okay, I want to add vector. Kenapa ni? Mengada-ngada nak save pula. Kejap. Hello, faster. Sekejap, saya punya PowerPoint ni tengah recovery pula. Okay. So basically I can do this in reverse. So I say, okay, I want to add vector A and vector small b. What do I get? I basically get vector capital A. So it's the same. So my vector A is broken down by its components from this equation. Boleh. So it's the same technique. And then I say, okay, I want to add vector E and vector F. What do I get? I get vector A over here. Boleh. So this is another way of seeing how a vector can be broken down. But the one that we are going to use is breaking it down in its x, ax, and its y component. Yang ni tak ada E, tak ada F, it's only x and y. So this is ax, a subscript x, a subscript x, okay? And a subscript y, or you just call it ax and ay. Okay, so how do we find ax and ay? Ada cara dia, okay? So this is one way of doing it, which I told you last time. Your vector is sandwiched in between your ax and your ay. When you want to break down your vector into its components, the components must be at the sides of the vector, okay? But there's another way to do it. This is the second one. The first one we talked about last class. First method. Second method, this is triangle. Boleh juga. So this is my ax, this is my ay. Does it look the same? This is going up, going up, going right, going right. It's the same. Okay? So boleh je. If you're more comfortable with technique number 2, go for it. My suggestion is to go for this guy because you will see, you will use this until end of semester 2. Okay? So this one is like the standard lah. Okay? But if you like this one for chapter 1, go for it. You will get the same answer. Boleh. Alright. So it is useful to use rectangular components. Okay, so a vector that is broken down into its ax and ay is called rectangular components. Why? Because if you try to connect them, they look like a rectangle. So it's called rectangular components. Or you can just call it components. These are the projections of the vector along the x and y axis. As you can see, ax is along the x-axis and ay is along, I'm recording, right? Ay is along the y-axis. Okay, so how do we find the components if we can't draw? Okay, if we can't draw, meaning to say, kita tahu, we know if I have a vector A like this, I know its direction is like this, ax, ay. But I don't know what is the length. I only know the direction, right? So how do I find out the length? So we need to use a little bit of math. Okay, so this tangent theta, theta is with respect to the x-axis, with respect to x-axis. Positive, positive x-axis. So theta is the angle of the vector with respect to the x-axis. X-axis is along over here, with respect to the x-axis. So theta is this guy. So tangent theta is equal to ay over ax. So let's say you know what is AX. AX, the value is 10 meter, contoh. So, and you know what the angle theta is, 30 degrees, contohnya. So 10 tangent 30 degrees equals to AY over AX. Hey, I already know what is AX, so I'm going to put that value there. Oops. What is it? 10 meter. Okay, and then I use my calculator. So how do I use my calculator? Untuk yang dah lupa nak pakai calculator for a while. Inverse tangent. So inverse tangent inverse tangent shift tangent. And then you times it with 10. Okay, so 84.29 is your answer. Betul ke? Kejap. This is in degrees ke radians? Oh, sorry. Salah. Tangent 30. Sorry, I'm not going to use inverse. Saya terlupa. Benda lain. Tangent 30. Mampu. Kejap. Times 10. Sorry 5.77. 5.77. Okay, so tangent 30. Tadi inverse. Saya tersilap. Inverse tu benda lain. So tangent 30 degrees. Make sure your calculator is in degrees, not radians. Times it with a 10. You move it over here, you get your AY. So that is how you can find the length of your vector y, vector AY, if you know one of your other vectors and you know the angle. If you have the length, 5 meter, 10 meter, but you want to know, hey, what's the direction of vector A? You can do that with the same equation. What's the direction of vector A? I am given with AY 5 meter, I am given with AX 10 meter. Use the same equation. I want to know what is the angle. Oh, tahu pula dah. Tangent theta AY is 5, AX is 10. 5 over 10 is 1 over 2, 0.5. So inverse tangent of 0.5 will give me theta. Inverse tangent of 0.5 will give me theta, which is 26.56. Oh, patutnya saya buat nombor yang sama. Sekejap. Okay, I wanted to show you something. Okay, so we found out that if AY and is 5 and AX is 10, I would get theta equals to 26.56, right? So what if I knew the angle? I should have used the same numbers just now. So what if I knew the angle over here and I knew what AX is, which is 10. I want to know what is AY. So tadi kita tahu AY, which is 5. What if we don't know AY but we know the angle? Would it give us the same answer? It should be. Okay, so tangent 26.56 AY, we don't know what AY is. I know what AX is, it is 10. So AY should be 5, the same as before because the angle is the same. Okay, tangent 26.56 times with 10. So I get 5. So AY is 5. Okay, so it should be like this lah. It should tally if your AY and AX, you know AY and AX, you should, and you get the theta. And if you want to do it in reverse, you have the theta, you have AY, you want to find AX. The values should be the same, cannot be different. So if your friend punya question is AY and AX, find theta. Your question is theta and AX, find AY. Your values should be the same. Tak boleh lain-lain kalau angle dengan components dia sama. Okay, that is my point here. Okay, any questions so far? Okay tak?
Okay.
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 Are there any part that confuses you? Let me know. Ada tak?
No.
Ada setakat ni okay. Okay. So if ada yang confused tapi malu nak cakap, you can also type it in the chat box or you can WhatsApp me, but WhatsApp saya susah nak baca waktu kelas. So preferably just tell me, don't be shy, or write it in the chat box. Sorry, my eyes. Macam mengantuk lagi. Okay, so vector components. AX is given by A vector cosine theta. This is another way of finding your component. AY is given as A sine theta. So how do we use this equation? Okay, let's find out. And then we have A vector equals to AX vector plus AY vector. This is the equation when you want to break it down into X and Y, or you want to add X and Y to get a component. So, okay, let's see what the next slide wants to tell you. Okay, so these equations are valid only if theta is measured with respect to the positive x-axis, as I told you before. Kita tak try lagi pakai equation ni, don't worry, jangan panik lagi. Okay, I'm just introducing this equation to you. All vectors can be resolved into components, yes, we know that. And the magnitude and direction given is A equals to AX squared plus AY squared, and theta equals to the inverse tangent AYAX. So we already talked about this guy, but we haven't talked about this guy, and we have not talked in detail about this guy yet. Okay, let me see the next slide. Kalau ada yang lagi senang nak cerita. Okay, tak ada. So let me go back to that slide. Okay. Alamak. Okay, so let's say I have vector A. Let's just come up with a random value first. So I have vector A. I want some space. Let's put this somewhere else. Make it smaller. We already know about this. I'm just going to make this smaller first, okay? What time is it? Okay. Okay, so I have a vector A. Vector A. Let's define it as vector A is 90 meters and has an angle of 30 degrees. Contohnya. Okay, this is my A vector. So A vector is happily over here. But his boss told vector A, hey vector A, can you be broken down into AX and AY? Because I need two of you to work. I can't have a single person. I need two. So A vector said, okay, let me break myself into AX and AY component. So how do I do that? I use this equation. Okay, so I use this equation. So this is where you put in your value, this is where you put in your length A. This is where you put in your length A. Length. This is also length. Okay, and straightforward, any very straightforward, just put in your angle of your vector. Okay, vector. Okay, so the difference between AX and AY, one is a cosine, one is a sine. So let's see. Let's use, oh patut kita pakai yang tadi lah. Okay, let's use this one. A vector is 26.56 degrees. Okay, kita dah tahu siap-siap tadi kan. AY is 5 meter, AX is 10. A vector is 26.56. I don't know the length yet. Ni rahsia patutnya, korang tak boleh tahu lagi. Sekejap, 5 squared plus 10 squared. I want to use all the values to be the same so that you know that it can be flipped around, switched around. So it's 11.18, okay. So let's say this guy is 11.18 first. Hopefully it's correct. Kejap. Give me a moment. Okay. So let's say vector A, kita tukar je nombor dia. So 26.56. 26.56 degrees and 11.18 meter. Okay, so this is vector A. The boss said, okay, can you be broken down into two people because I need more of you to work. So, okay, A cakap boleh, let's do it. So, dia pakai this equation. So, this guy over here needs to be the length. This guy over here needs to be the degrees or the angle. So, AX is equal to A length 11.18 cosine of 26.56. Okay, can someone use their calculator and calculate this for me? Make sure your calculator is in degrees mode. And then another person, please calculate AY 11.8 sine of 26.56. What do we get? Okay, kalau tak ada orang nak volunteer, saya akan panggil nama.
AX 10.
X will be 10.
AX is equal to 10.
AX 10.
Okay, what about AY?
5.27.
AY equal 5.
AY 5.
5.27.
5 point?
5.2.
0.
5.999.
5.3, 5.27.
Oh, jauh juga.
11.8 or 11.18 for the A, doctor?
7.18. Sorry. Tertinggal. Okay, lagi sekali. 11.18. Dapat 5. Patutnya lah kan? Times sine.
5.
Dapat 5.
Okay. Okay, sorry. Tertinggal satu. Okay, so as you can see here, the AX is 10 and the AY is 5. If I use my vector as 11.18 and the angle as 26.56, I use the same values as before. So if I didn't know what AX is, I didn't know what AY is, I only knew about A vector, I can still find them out. And it would give me the same answer as if I knew what it is. Okay, so it should tally. My point here is your answer cannot be different than your friends if you have the same question. Okay, so kena sama. Walaupun nampak macam complicated, but it should be the same. Okay, so now that we know how to find the X component, the AX component, and the AY component, or the X and Y component of a vector, you have to know the length and you have to know the angle. So what if I know what is AX and AY, but I don't know what the length of my vector is? I don't know what the length of this guy is. What's your length? Okay, so I can use that if I know what AX and AY is. So A magnitude is equal to, let's put it like this so that you know it's a magnitude, AX squared plus AY squared. This is also magnitude. Okay, tak payah letak angle dia. So if your AX is 10, your AY is 5, let's try to do it. Alamak, buruknya equation saya. 10 squared plus 5 squared, square root of that, I should get 11.18 balik. Let's try it. Squared plus 5 squared, square root of that. Okay, did anyone get 11.18?
Yes.
You got
Yes.
11.18. Okay. So now we know how to find the angle of a vector, right? Tangent theta equals to AY over AX. We know how to find the magnitude of a vector, AX squared plus AY squared, square root the whole thing, you get the length. Okay, put in the units. Or if you have the vector you want to break it down into AX and AY, use A cosine theta or A sine theta. So let's do a recap of what we have learned in another slide so that everyone is on the same page. So if I have a vector A, I want to break it down into AX and AY. Okay, I should know the length and I should know the direction of my vector. Okay, so how do I do that? AX is A cosine theta, AY is A sine theta. Okay, so this is one way. And then what if I know the AX and I know the AY, but I don't know what my A is, my A vector, my resultant vector. So to do that, tangent theta equals to AY over AX. This will give you the direction. And then for the magnitude, A is AX squared plus AY squared. So my final answer will be A vector is length, whatever, and the direction is angle, blah, 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 with respect to the x-axis. This equation will only give you angle with respect to the x-axis. Okay. This is, if you have a vector, and this is if you have ax and ay. Okay. Moving on. We have 15 minutes to go. This is 3D. Do I want to tell you about this one? Okay, let's just go over it lah. Okay, so if our A vector is in 2D, we only have the X component and the Y component. But your vector can also be in 3D. So this is your starting point. It started from 0, right? From the, bukan 0, panggil apa? Origin. And it goes to this point. Okay, but if I'm viewing it from X and Y coordinate, I will only see like this. I will only see this guy. But if it's in 3D, I will know that it's actually extending in the Z coordinate as well. So my point here is that vector is not only 2D, it can also be in 3D. Okay, tapi in our syllabus, kita akan tackle 2D problems lah. Okay, 3D is quite complicated a little bit. Okay, but you have to know that vector is actually, it can be 3D. It's not only 2D, okay? So if my vector that we talked about just now was A equals to AX plus AY, X is the I and J is the Y. So if it's in 3D, it will be okay, if it's in 3D, it will be AX plus AY plus AZ. Adalah teknik dia. And then this will refer to your X vector, your X direction, Y direction, and in the Z direction of the coordinate. Direction, this indicates the direction. Yang ni value. Okay. Do you have to know, ni saya tunjuk as an intro lah. You will see this in your degree if you are taking science punya degree. Science, any science actually. Engineering pun ada, physics pun ada. What else? Bio, I'm not sure. Math for sure ada. Okay. So I'm just introducing this to you guys, but we will only use 2D, AX, AY. We won't use the I and the J yet. Okay. All right, so resolving into components, resolving vectors into X and Y component. We talked about that. We use A cosine theta, A sine theta. The components can be positive or negative. Kita tak tackle lagi part ni. We only talked about when it's positive. Okay, nanti kita akan buat problems on this. So this is AY positive, AX positive, BX negative, BY positive. Okay, negative, positive, positive. This is D is already in the X component. So it's D is just equal to DX positive, right? And then C is already in the Y component, CY positive. Okay. Kejap. Addition into using components method. Okay. How do I tell this one? Okay, so now this question is tadi question lah. This question yang saya nak make up ni is asking you, hey, what is vector A plus vector B? So this is the question. What is vector A plus vector B if we are using the component method? We don't want to use the tip to tail. We don't want to use the tail to tail. We don't want to use the triangle rule. We want to use the component method or the panggil apa? Rectangular component method. Panggil component pun okay. So how do we do that? Okay. So as I told you before, if you're adding vectors, you must be adding the same kind, like Newton plus Newton, meter per second plus meter per second. It must be of the same kind. Okay, so how do we do that? So A and B, they are not in the same direction, so it's not that straightforward. So what do I do if I'm going to use the component method is I break it down into its X and Y components. So this is the X and Y components of A, or Yang kita suka is this way. Saya sukalah AY this way, AX this way. Your vector is in between the components. So one component AY, one component X. And then for B, we have, kejap I think you already know what I'm going to say. We have the X component. Excuse me. Let me move this over here because it's the same thing basically. Okay, so this is my AY and my AX. Let's remove this. And then this is my BY and my BX. So saya nak tambah these two vectors. Okay, I want to add these two vectors. So I resolve them into AX and AY, BX and BY. So if I'm doing this and I want to add the AX and the, I want to add them together. So I have to add the X components together and the Y components together. Okay, so this is the resultant. Sorry, saya macam gagap sikit. So resultant of vector A and vector B is Rx is equal to Ax plus Bx, adding of the same kind. And then we have Ry, Ay plus By, adding of the same kind. Okay, so now that we know that we have to add Ax and Bx, Ay and By, so basically, kalau saya nak lah, I can add them by graphical method, or I can just add the values together. So this is By plus Ay. Tapi untuk komponen pakai value je lah, janganlah nak melukis. Menyusahkan diri je. Okay, so Ay and By. So rupa dia macam ni if I'm adding them together. Ay plus By, if I'm adding them together, it would look like this. Okay. And then your Ax and Bx, if I'm adding them together, okay, it would look like this. And if I want to know what is the resultant, sebenarnya kita dah belajar cara nak cari resultant by using the equation yang this guy, Rx squared plus Ry squared equals to R, and also to find the angle Ry over Rx. Okay. But if you want to imagine it, so you add Ay and By like this, Ax and Bx like this. So using the, what do you call it, tail method, tail to tail method, your resultant will go over here. And it's the same as if you are using tip to tail, and it should be the same as if you are using the equation. It should be all the same sebenarnya. Okay, I realize this is quite confusing. Okay, let me repeat myself on this one. Okay, let's go back to when it all began. Alamak, tak boleh pula. Stuck pula dah. Sekejap. Okay, let me repeat myself. I realize this can be confusing for first time. Okay, vector ni. Okay, so back to the question. I said, okay, what is vector A plus vector B? So vector A plus vector B, kalau kita pakai tip to tail method, we will find out that if I'm using tip to tail, if I'm using tip to tail, A plus B would give me, from the beginning to the end, it will give me something like this. Okay. If I'm using the tail to tail method, let's try it. Kita pakai arrows ni je. I'm using the tail to tail method. So I should put it over here. Okay. And then remember, I have to have something that is parallel to A. I have to draw something that is parallel to A. But let's make it a different color. For my shape, this should be a dash. And let's use a green. Okay, so I have to draw something that is parallel to A and something that is parallel to B and connect them together. So this is tail to tail. Okay, green and dash. Okay. So this is when I'm using tail to tail. So sama, resultant goes from here to the end. It's the same as if I'm using tip to tail method. Okay, so we got that clear. Any questions about tip to tail and tail to tail so far? Before I go on to the
No.
component, okay eh? So semua orang dah bosan dah dengan
Okay.
tip to tail ni. So let's go for the component. Okay, so delete this first. And then let's assume we don't know what the resultant is yet. Let me put it over here. Close this. So this is our resultant. Okay, so I want to add A and B. And I know that I should resolve it by its components because I want to use the component method. So BY, tak sini dulu. BY, this is the component for BY. And this is the component for BX. Okay, and then I have another vector called AY, called A, and the X component is over here, and the Y component is this guy. Sama pula. Okay, saya dah lupa rupa gambar tadi macam mana sebenarnya. Kejap. So this is AX ke tak? Okay, let me just redo this. Confusing. Buang. Okay. BY and BX. Control B. Kita buang A dulu Kita buat B dulu. So B punya komponen should be BY positive, BX positive. Okay. Ni kalau lukis lah. Korang lukis lah. Janganlah buat pakai PowerPoint menyusahkan diri macam saya ni. So this is your BY. Okay, saya nak lukis sebab nak bagi cantik. Sebab saya sedar saya punya lukisan buruk. So let me just do it nicely. Okay, so this is X. Okay, that is your X component and Y component. So you have your A component and it's over here. It's a side. Tak jumpa jalan. Hello, come back. Okay. So this is your A component. A component. A vector. Okay. Sama juga kita resolve. Resolve into its X component and its Y component. Okay, so let me do that. So kalau korang perasan, Y untuk B kan, it should be, kalau nak lukis lah, the length should be like this. It should follow the top of your vector and BX patut follow juga. So yang tu tersilap. This guy should be like this. Okay, so that is the length of BX and BY if you're drawing it. And then you have your AY. Let me draw a parallel line before I screw up my drawing. Okay, so this should be smaller like this. And your AX should be like this. Okay, so now I want to add these two guys together. Because why? The question asked me to. Even though I don't want to, but the question asked me to, so I have to do it. So what is A and B? A plus B. I don't know what it is, right? So I told you resultant. This is equal to resultant vector. So Rx is Ax plus Bx. And Ry is Ey plus By. So adding these components together, let's try it. We would get resultant that looks like this, but we don't know yet, supposedly. Okay, so Ax, let me duplicate this slide first. It's bugging me. Buang semua. Oh, thank you. I want to duplicate this one je. So let's see what happens. Okay, so Ax over here, I'm adding the X component together because they are the same kind. Okay, and then your AY together because they are the same kind. So this will be my Rx and my Ry. Let me label it. This is Rx. This is Ry. What is Rx? What is Ry? Ry is Ay plus By. Rx is Ax plus Bx. So what is R? What is the length of R? R should be Rx squared plus Ry squared. Square root the whole thing. What is the direction? Theta, tangent theta equals to Ry over Rx. This is if you're using math. If you're drawing it, Ry, so this is A, saya dah lupa, tak apalah. Korang tahulah, this is By, sorry, Ax, Bx. So the resultant should be from the tail to something that is parallel, like this. Okay, so let's see, sama tak dengan apa yang kita tengok sebelum ni? Sama. Sabar sekejap, saya ambil dulu. Sebenarnya leceh lukis-lukis ni, which is why component method by math is like the best method. Yay, sama, walaupun lukisan saya buruk. Okay, so you should get everything the same by drawing tip to tail, component method if you're drawing it, or component method by math. Semua patut sama. If you want to cross-check your answer, use the math. If you can't cross-check your answer by the math, cross-check it by other techniques. Boleh. Should get the same answer. If you don't get the same answer, something is wrong somewhere. Okay? So I hope that was clear. We used all techniques in one question. So what if we have we have 4 vectors. Tadi we talked about 2 vectors. What if we have 4? So macam sama juga. So we want to find out what is the addition of A vector plus V vector plus C vector plus D vector. What is the resultant vector? Sama juga. So Rx is equal to Ax plus Bx plus Cx plus Dx. I sound annoying, but this is what it is. Ay plus By plus Cy plus Dy. Macam tu. Yeah, and then use the math is the easiest way. And then how do you find the magnitude? Rx squared, Ry squared, square root the whole thing. That is your magnitude. Direction, Ry over Rx. Always Ry kena dekat atas. Y is at the top. Kena ingat itu. Kadang-kadang tertukar letak X kat atas. Okay, so sama je. It's the same for any number of vectors. It's the same. You break it into its X component, add them together, break the vectors into its Y component, add them together, find the magnitude, find the direction. Okay. Okay, so the magnitude is basically based on Pythagoras theorem. I think you are aware of this. So Ry, Rx. So you want to know what is R? It's basically Pythagoras theorem, right? This is A, this is B, this is C. A squared, B squared equals to C squared. I want to know what is the length of C. So C equals to A squared plus B squared square root. Looks familiar? Yes, it should be Rx squared plus Ry squared equals to R. Okay, it's the same thing, Pythagoras theorem. And then the inverse tangent function to find the direction of R, the angle with respect to the x-axis. Okay, so you will find out, you will apply this concept or this knowledge in problems nanti. I will assign problems in WebAssign and you will try that. WebAssign is your assignment if you forgot, but I haven't assigned yet. Sabar dulu, kita habiskan dulu chapter ni. Okay, so problem solving strategy. Read and understand the question. Oh, kita dah terlebih masa, so sorry. So I guess I'm going to end class here. Any questions? If not, then you are free to go. I'll see you next week.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome. Bye-bye.
Doctor, can I ask again later on? I want to ask about the sketching that you do before because I got confused a little bit.
Boleh?
Okay. Thank you, Doctor.
Okay, bye.